now. So I hope you can see my slides and everything is working. Yeah, so Svea, Jens, thank you so much, and Birgit for inviting me here and having me. It's a pleasure to be part of this series. Um, so I'm not a full-time theorist as some of the other speakers that have been presenting here, but rather I'm something in between. I like to mix theory and practice. As Birgit already like introduced, I come from a background of design, but then did my PhD in media theory. And I think this is like a very interesting field where I'm capable of mixing these things. And making something that is like always negotiating practice with theoretical bounds. And in this talk, I will try to mix those two things together. So what do we get if we mix media design and media theory together? And I will go through the loops, a couple of them throughout this talk. But just to give you an idea what I'm doing in my practice, here's a supercut of my work over the past 15 years, roundabout. So I've been doing this data visualization work where I'm taking data sets, working oftentimes with scientists and turning them into this graphic representations. This moved from working with physicists. I lived in Boston for some time, working at the Center for Complex Network Science, to working with theorists from media theory, digital humanities, and all kinds of other fields. And also then having my own media practices. In between, you see a couple of pieces that I made with a performance group in Berlin. So it's a really wide spectrum of things. In northern Spain, researchers have found this stone, and they figured out that it dates back 14,000 years, so to the time of the Stone Age. And if you look closer, you find this kind of etchings, and these etchings are actually information that are encarved into the stone. So humans have been visualizing information for over 14,000 years. We know this by now. So information design, in a sense, is much older than marketing or branding. Um, the storing and the communication of information is with us for thousands of years. And here you see, like, researchers have investigated this stone and looked into the carvings and what people actually tried to visualize by doing this. And I find this truly fascinating. At the time, they basically marked down where they hunt deers and they marked down where they can drink water. So this was basically a map to understand the world. And this is something really interesting where we take a piece and we externalize reality onto something, into symbols. And this is not, of course, not the only piece. I want to show you one more of these. This is called a stick chart. And it's an arrangement of bamboo sticks and little shells. And what is represented here, it's a map of the oceans. So basically, the blank spots are islands. And then the flow of the water are basically graphed by the bamboo sticks. So this was made in the Marshall Island region to navigate the oceans. And in this case, it was very important for the people using this that the map was actually matching the territory. So if you have like strong currents, you could get really into trouble if you map out something wrong. And I think this is what information design is doing. It is always this connection between abstraction and reality and drawing those two things together and synchronizing them in a way. So visualization is a technique that brings together a certain model of the world as an abstraction and matches that with reality. And this semester, I gave me the task to teach basically an introduction class to my students. And in information design, I'm the professor there since January, and I thought I should do this. And while preparing that class, I realized that I'm not a fan of any of the definitions that are out there of information design. So right now, I'm basically creating my own and figuring out if that works or if I'm on the wrong path. And I thought I'll share this with you here. So maybe this is something we can discuss later on. As I'm kind of interested in this right now. The workings theory is pretty basic. It's based on semiotics and this idea of Charles Sanders Peirce, of Ferdinand de Saussure, of the sign and the three different parts that the sign needs to be in the world. So it needs something that's signified by the sign. It needs a form of the sign, signifier, and it needs an audience or observer, the interpretant. And the signifier is what I'm interested in because Peirce categorizes this in three different categories. First, the icon, which has a resemblance to the actual place that it represents. So, an example for this is basically something like a tree. So the icon has a physical resemblance of the signified, the thing that's being represented. A photograph can also be an example of this. Mm. Then we have the symbol, and the symbol is something that is completely abstracted. So the symbol has no resemblance with the signifier. So there's no connection between those two. They must be culturally learned. So numbers or alphabets are a good example. If you don't know the meaning of the signs, you can't interpret them by just looking at them. So they are always culturally learned. So if I place the German term here, you most probably understand its meaning. And then thirdly, there's the index. And the index is meant to show evidence of what is being represented. And a very common example of this is an image of smoke that indicates fire. But I also think this is where information design lies. So this is a map of all the trees in Germany, and this is a evolvement of trees and how much forest is basically covered within Germany by trees. So, and I think these are like indexical representations, and this is what information design is doing. Um, so just to go through this one more time, we have like the icons, which are representations, and we have abstract symbols and indexes. And I think this is like something that I'm trying to use at the moment to basically distinguish what we're doing in information design, working with indexes, against what my colleagues are doing, which is all communication design. So creating icons, creating symbols, that is what people do in illustration or what they do in typography. But I think information design is tightly coupled to this idea of the index. And with that, to the idea of representing evidence. And I recently published a book which goes much deeper into this. And at the end of my talk, I will dive a little bit into that theory. And the book is about the epistemological value of design in the context of computational systems. So the questions that I'm asking throughout the book is, why do humans visualize data and what are the motivations to do so? And uh, when I'm looking at the literature, there are very clear motives for why people say that they are designing data visualizations. Mm. So there is a very common and strong agreement what these graphics are doing. And I'm just going to read out a couple of them. The purpose of visualization is insight, not pictures. Visualizations accelerate rapid insights. The holy grail of information visualization is for users to gain insights. Images are an alternative and seemingly direct route to insight. Data is a kind of ubiquitous resource that we can shape to provide new innovations and new insights. And it's all around us, and it can be mined very easily. Visualizations convert data into insights. We want to simply and effectively exploit and use the hidden opportunities and knowledge resting in unexplored data sources. Data, information, knowledge. We distill it into beautiful, useful graphics and diagrams. Graphical excellence begins with telling the truth about the data. So these are just a couple of examples of the quotes that I've found in many books and many research papers that are describing why visualization or why the representation of information is important. And I collected these and clustered them and reflected upon these statements. And the interesting thing that happens is the closer I observe the actual descriptions of the design process, the further away the notion of insight, knowledge, or truth that people talk about, oftentimes in introductions of their books. So we use these terms on covers, but we don't really know the connection between design, insight, knowledge, or truth. And there are within the application side, there aren't very many things that connect this. And once we look into this, new objectives emerge that replace this idea of insight. And I won't dive into the full theory, but I want to give you one example of things that I collected and clustered, and that are the design processes. So what you see here is a collection of 27 data visualization process diagrams. And while they all look different and they all have different parts that are embedded within them, they all follow a very clear narrative. And that narrative follows something like that. It's, I think, the promise of data visualization that boils down to the idea that we first capture the world in data, then we visualize this data, and then thirdly, we gain insight into the world by doing so. And I have to say, I've been doing this for, I think, 12, 13 years, and the results of this are kind of interesting. And I have a lot of work where I'm basically following this exact process. So this is an early work of mine where you basically see the visualization of movie references throughout the 21st century. So you see the 19th century at the bottom, and at the top you see the 2000s. And each little dot, each little icon is one movie. And then I looked at the IMDb, the Internet Movie Database, and they have references in there. So people write down if the same quote is used in a different movie, or if they have the same costume, or if a director said that he was inspired by a certain movie. And I basically mapped out that diagram and visualized this. And in cinema theory, this is known as the rise of the postmodern cinema. That's a really red part at the top. And that's an era where it became very common to reference a lot of movies from the past. What you see here is a piece that I did while working with Laszlo Barabasi in the physics department of the Northeastern University, and it's an ecosystem, a network of species living in a coral reef, and what you see at the bottom is basically the collapse of the ecosystem. So, what happens if certain species die out, and how will the ecosystem react to that? This was a piece that I did at the inauguration of Donald Trump's first presidency. And it's a network of all the companies he's involved in and all the people who are then on the board of these companies. And it just showed this giant network that he is embedded in, and it became very popular. It's about 1,500 individuals and companies that are connected to him. And for me, it became this kind of map that I did, and more and more names appeared throughout his first presidency that became part of the government or that played a role within the government. So for me, this was basically a map that gave me already a view into the comings of his first presidency. This is a clustering of all my colleagues downloaded 32 million websites, all websites with the ending .gov, so all government websites of the United States. And we took this massive data set and clustered them into pieces to try to understand what the US government is actually doing for its citizens. And this became the first kind of map of this kind for political scientists. And then my work spans all the way to the universe. And this is a piece called The Cosmic Web. Every point is a galaxy. So the entire Milky Way within this graphic representation is represented within one dot. It's the largest model of the known universe that we have, that is represented here, and the connections here are basically gravitational forces between the universes. So, and by giving you or showcasing you these works, I wanted to highlight that the notion of visualization is a very powerful one. It makes us see data and lets us draw images of these oftentimes scientific inquiries. But something that is important is that neither data nor visualizations are ever neutral. Visualizations are always made, they're always created, crafted, and designed with specific ideas, concepts, and ideologies in mind. And this is something that I have experienced myself very well. Um, in the Cosmic Web project that I just introduced, the simplest model was, in my opinion, also the computationally simplest model was, in my opinion, also the most beautiful one. And it had the best correlations to the observational data that my colleagues were looking at. But once we published this work and made these interactive graphics available on the internet, something different happened. We got a lot of comments, such as this one. Perhaps the universe can be thought of as God's brain. Or people put it more simply, we live in brain. Or other people had a more artistic approach. God apparently thinks he's Jackson Pollock. So, when working with the scientists on these ideas, they had a very specific idea. They wanted to basically redefine and improve the algorithms that they were working on. But once we published this, the scientific research got interpreted from very different angles by very different people, and this made me think quite a lot. It's not just about the data, the visualization, but also the ideas, the culture, the beliefs of the people interacting with these graphics. The scientists looked at the visualization in a certain way, but other people did so as well. The universe does not look like a brain. I made it look that way. We, as the creators of these graphics, have a powerful role in shaping the ideas and the connections of the reality that we live in. And there's something happening that I find quite fascinating in this space. On the one side, we often naturalize the machine from data centers as clouds or statistical models that can think in the form of AI. Simultaneously, we oftentimes mechanize the human from imaginations of the human as steam engines in the 17th and 18th century to humans as industrial systems, as here represented by Fritz Kahn in the 19th and 20th century. So we have this connection that interfaces guide of this cultural layer and of this computational layer that we kind of often mix together and have this strange kind of overlappings. And I think this is where art and design come into play and basically capable of creating new forms of interfaces and questioning these relations that we're drawing out. We can make certain metaphors and neglect others. So throughout, I would say, the past 8, 9 years, my perspectives on this graphic that I just introduced became more complex. And the notion of visualization and that it's capable of representing insights got a bit of questions related to its meaning. And what is often neglected in this process are the mediations that are happening from reality to data and from data to visualization. And over the past decade, I'm researching that notion of media reflexive visualizations that make the cracks, the strangeness visible. Um, so the connection between visualization and the world becomes more complex, but also more interesting by looking at things that are happening in between. So the mediations. And here I'm mainly interested in these two notions of form and space that I will get back to later. In the context of design and design books, I can highly recommend this book by Ryan Hux. It's called Culture. And on one page, he writes that we're at the very beginning of recorded history. And data seems to be able to represent everything in the world. It is the ultimate meta medium, able to represent any other structure from text to images, sound, video, to data formats such as statistics, networks, and so-called complex systems. We have more information nowadays about any average citizen than about a king, celebrity, or famous thinker of the past centuries. But in this process, where everything is becoming data, I'm questioning what are we missing? What is it that we're leaving behind from reality that we live in? What is there that we cannot capture in data and that we're thus removing from the world and how we process it by digitalizing everything? So I became interested in showing or using visualization to not show what data can do, but also what it cannot, where it fails. And I want to show you one project that I think is particularly strong in that sense. The project is called Situating Me Too, and it's a project I worked on with Catherine D'Ignazio, Cole Martin, and Matthew Badils. And it was a project, a research project on Twitter data of the Me Too movement that I did while being researcher at MetaLab at Harvard. And there is an interesting tendency that is happening where libraries started not only to collect books and artifacts, but also data sets. And at Harvard University, there's a specific library called the Schlesinger Library. It's a library on the history of the woman in America. And they started, when Me Too happened in 2017, they started collecting tweets on the movement and created a data set of over 30 million tweets with the hashtag #MeToo and related topics. And they had a grant writing and asked people to submit project ideas that people want to work on this pretty large data set. So in 2020, we started this. And when looking at other pieces that have been done when it comes to the topic of Me Too, what we found is that a lot of visualizations often look at superlatives of the movement. So the top cities, the most liked, the most frequent, the most shared. And this is a very common method in data visualization, but also in data science. It's this global perspective, filtering and predefining what is made visible. And this goes along very well with a famous mantra in visualization design by Ben Schneiderman from the 1990s, which is overview first, zoom filter, then details on demand. It's this information-seeking mantra. But already in 1988, Donna Haraway questioned this notion, naming it a view from nowhere. In her article, Situated Knowledges, she called this the God trick. It's a perspective that can lead to a false sense of completeness and objectivity. So when we started this project, we immediately followed the God trick. And what we did was we took a random sample of 1 million tweets from the 30 million between 2017 and 2020. And we looked at the tweets with over 100 retweets. In total, this were 892 tweets from the 1 million tweets. And then we went into and investigated this by doing some close reading, meaning we read through all these almost 900 tweets. And this was a really interesting and sobering experience, because 153 of these tweets were actually violations of the rules of Twitter, which is most likely all of them had the same, or almost all of them had the same number of retweets. And my suspicion is that this is bot activity. So these are robots talking to one another. Then there were a couple of tweets also with a lot of retweets that were no longer accessible. They most probably violated the company's terms and services at that time. And then there were a lot of tweets that were actually about Me Too, but from a political perspective, discussing Donald Trump and the then Supreme Court Justice Brett Kavanaugh. And what was really shocking was that only 9 of the tweets, of the almost 900 tweets, were about sharing stories of what happened to individuals related to Me Too. And that made us very suspicious. It was like, how can it be that only so little a spotlight was given to these tweets? And I created a little interface, and as a team, we went through quite a lot of tweets, and we looked at things, at tweets with certain hashtags, with certain perspectives, all without any like, any comment, or any retweet. So things that maybe almost probably nobody ever really looked at or engaged in. And a very common method when dealing with large data sets is to filter out the unconnected, filtering out this data that has no information attached to it. It's a very common method working in large-scale data processing. But in this case, what if the important information is in the non-connected? So this became pretty interesting. And what we actually found is that a lot of what we call hashtag Me Too is in the non-networked. It is not connected to anything else. It's in the parts of the network that is never shared. Later on, we actually found out that this was policy from Twitter. So they basically put on in their algorithm, they put on a rule that removed a lot of the things that mainly women shared what happened to them, because the company didn't want that you go onto the media platform and see this negative post, see the horrible stories that people were sharing. So it's something created from these systems, from these algorithms, and from these companies. So what we did in the end is we made these visualizations of the non-visualized, of the non-represented. And we made 4 graphics of the lost and forgotten tweets of Me Too, highlighting some of the things that are unobserved, ignored, and unseen within the space of Me Too. So in this sense, data means power. Focusing on the apparatus, abandoning the superlatives, allowed us to question and reflect upon the notions of insights, and in which models they actually hold valid. What if the network, in its temporal emergence, is not about the points and lines it is seemingly abstracted as? What if the metaphors, the models, the capturing does not represent what actually matters? What if the network is rather about the negative spaces it creates? What if the community is living not in the networked, but in the in between, in the cracks, in the things, in the holes, in the non spaces, the void, the in betweenness? Within these visualizations, I'm not highlighting the network, but what becomes visible is the algorithm that is drawing the network out. It's like visualizing the forces that are used. This is a force-directed layout. So we see how the algorithm is trying to make the network visible. And by doing so, we're visualizing the past traces of this algorithm. And this relates well to what Wendy Chang calls homophily, or love for the same, that grounds network science. Similarity breeds connection. When ChatGPT got released to the public on November 30th, 2022, I started making requests to the system what knowledge is. And I quickly found out that the system is not only capable of generating linear forms of texts, but that it can also generate small data sets. And that got me pretty interesting in what I can do with this. So I started having these conversations and I started creating these tables of categories and subcategories of knowledge. And in the end, I had this really long lists of terms. And they reminded me of short stories by Borges or Kafka, the strange categorical creatures of inclusion and exclusion. And I took this data and actually started scraping more data on top of this. So I asked for humans, objects, things, and ideas that are connected to these topics and subtopics that I scraped before. And from this, I built up, with 1,800 requests to the system, I built up a large data set of things that are important to ChatGPT. And from that, I constructed a co-occurrence network where these kind of levels of information are related to one another. And then again, I calculated the best position of these data sets by force. So things that are closer to one another have more things in common than things that are further apart from one another. And this drew a map. So on the bottom corner, you see health and medicine and psychology and education. And those things for ChatGPT have more in common to one another than film or arts or literature that are located at the top. And then the subcategories, the items and the related items. And the final map looks something like this. Um, the result of this process is what I call artificial worldviews, a mapping of algorithmic conversations with ChatGPT. Machine learning is often referred to as a black box, but we can access this black box very well by talking to it. Individual queries can only lead us to anecdotes. However, structured inquiries in large quantities can give us new ideas of what these systems produce. Friedrich says, where there's nothing to calculate, we don't need computers. He's an early a computer artist. So to understand what these systems are actually doing, we have to understand how they are functioning. So what is calculated? How to calculate language, ideas, thoughts, and sentences? And Nick Crawford called called AI a registry of power. And I think this is pretty interesting for this diagram that I visualized in the beginning. I think what I showed you and what the change is that I done in the work is that I switched from the idea that I'm capturing the world to that I'm capturing systems. And this switch changes our perspective, and something else comes into focus. In the case of large language models, we can now investigate the origins and the politics of data. By far, the largest data set that ChatGPT is trained on comes from a system called the Common Crawl. The Common Crawl scrapes billions of websites every month and stores them in textual data. This means if you have posted something on the internet, on social media, or your own website, it's most probably part of this data set. This means ChatGPT is us. And there are a lot of people who are unhappy about this. The scraping of all data from the internet lead to many upsets from Hollywood writers, novelists to journalists. But there's another problem. The internet is not built on the purest knowledge of humankind. Bullying, trolls, stalkers, crime, pornography, just to name a few problematic areas. And to counter these problems, um, OpenAI, the company behind ChatGPT, used a lot of human labor, especially in the global south, and paid them very little, less than $1 per hour, to make the system less toxic. And the third layer that I became interested in are the infrastructural layers. ChatGPT is extremely energy hungry in compute, in energy consumption, but also in water consumption to cool the systems down. So by switching from world to data, we can suddenly investigate the factors that are leading up to a map like artificial worldviews. We can ask what are the structures, the foundations, the principles leading to certain data sets and certain visualizations. So from this basic idea, from this basic three-step from world to data, I added and removed certain concepts. We switched into this media reflexive notion of form and space, and moved from world to systems. I think it's a more humble approach of what visualization can do, but it also leaves open a completely new range of possibilities. And then thirdly, we switch from insights to power. Observing people, observing systems lets us investigate their power constructs, making visible what is drawn inside by whom. So coming back to this really simple idea of working with data as an abstraction of reality, we see that the problems are much more nuanced. And something that I did in Insight by Design is that I investigated quite a lot of design processes. And what I asked myself is, what is design and what is the smallest act of design and how does it relate to insights? And here are just a couple of examples. Some of them are from my own work. At the top center, you see a design process from the New York Times. Some of them are from other people. On the top left, you see a tutorial. And I looked at what is actually the smallest step of design and what is it doing. And I couldn't find anything in design, computation, or media theory. But I found something in the very essence of mathematics. This idea that the first command is to draw a distinction. Um, it's a theory that originated by the mathematician George Spencer Brown. And he said that mathematics, the basic understanding of mathematics is to draw a distinction. But I think his theory is much more pointed towards computational systems. And he introduced this diagrammatic notion that I applied to visualizing design processes that I'm calling the calculus of design. A calculus is a step-by-step instruction, and the command to draw a distinction is based on two lines drawn together. Within the diagrammatic notation system, there's only one other symbol, the re-entry, which is the shorthand for a nested set of repeated distinctions. And we see this kind of usage a lot in representations of code. When you program something, you often take something, as in this example, you take a data set and you apply rectangles. But only by drawing a distinction in the rectangles, only like in this case, they all have the same X and Y and width and height. So you only see one rectangle, but only by drawing a distinction, they basically become visible. And this is a very simple perspective, but I think a very powerful one. And this is the first axiom of the idea of the notion that only a difference makes a difference. So only by doing something that you haven't done before, that becomes visible. So, and from here we can add on quite a lot of layers and look at what is actually drawn inside, how to create a bar chart or any other visualization. But not only that, we can look also at the spaces above that, the predefined distinctions, as I call them. And there's a conglomerate of these spaces, from the SVG that I'm drawing in, the JavaScript that I'm using to make the graphics, the HTML environment, the render engine, and the processes that lie beyond that. It's always this conglomerate of nested spaces that is, for me, the medium which I design. And these spaces are oftentimes in computational system, they look blank, but they're not blank after all. They're filled with pre-assumptions, pre-configurations. And design becomes a game of finding novel sets of distinctions within these predefinitions. The contingency of the space defines the possibilities of design. This is a famous chart by Hans Rosling, and another designer from Berlin, Lisa Charlotte-Muth, recreated that chart with a specific other tools. So the data always stayed the same. And she did it to test out what are all the tools that she can draw things in. But I found it so revealing in showcasing like how much the medium, how much the thing that you're using to create something predefines how that looks like. This is all the same data, just very different forms of representing it. So from that, I came up with this kind of idea of what design is. You choose a medium that predefines the possibilities that you have, that you're working with, the applications, the programming environments, or pen and paper. This space is a space of possibilities you have at every point that you draw a new distinction. Design is the act of moving through this space by drawing distinctions. Each step you ask yourself, what are you leaving behind by drawing another distinction? The entire book is structured in this form and holds more chapters that are related to this. And I want to leave you with this very last idea of what design becomes when we're looking at this. The calculus of design renders visible an alternative relationship between design and insight. The thesis is that insights are not discovered, gained, explored, revealed, or mined, but are operatively designed. To understand what insights are, we have to map the processes leading towards them. The processes, structures, and perspective the designer is embedded in and operates from need to be rendered into focus. The diagrammatic notation draws out these layers of the design operation. It is an approach towards visualizing the step-by-step procedures of design. Design is thus an act of exclusion. The possibilities of space are crossed into form. The operational loop is gradually redesigning our understanding of the world that we're embedded in by being constantly on the edge of something else. Thank you so much.